So in this video, we're going to see what happens to experimental probability as the sample size increases. So just to run over the terms here. So what is a sample size? Well, if we did a questionnaire, so if we did a questionnaire, so if I just put a Q and A, well, we could ask a sample of 10 people, we could ask a sample of 100 people, we could ask a sample of 1 million people. So for something like a questionnaire, that would be our sample size, how many people we pick. Or if it was an experiment, it's how many times we do the experiment. So in science, let's say that we were dropping a ball to the ground. So dropping a ball to the ground, we could drop the ball once, we could drop the ball 10 times, we could drop the ball 1,000 times. So that's really what sample size is. Okay, what's experimental probability? Well, this is the example that I'm going to use later on. So if we flip a coin, so a coin has two sides, right? So if we flip a coin, we can either get a head or we can get a tail. So if we flip the coin 100 times, well, we'd expect that we'd get 50 heads and we expect that we'd get 50 tails. Okay. So that is a very ideal situation. So this is what we call theoretical probability. So it's what should happen in theory. So think about science, something theoretical. It's what should happen if everything was perfect. So theoretical. However, in reality, if we flip a coin 100 times, we might get 30 heads and so we might get 30 heads and we may get 70 tails, say. So that, when we do the experiment, in reality, that is called our experimental probability. So experimental. So our experimental probability. Okay. So what we're going to look at in this video is what happens to our experimental probability as our sample size increases. So as we increase the sample size, what happens to the probability in our experiments that we do? So I'm going to carry on with this idea of a coin. So the way that I like to think about this is, well, if we're doing an experiment with a coin, where we're going to flip the coin, so what are the outcomes of this experiment? Well, we can either get a head or we can get a tail. Because there's only two options, we would expect that we've got half a chance, so 0.5 chance of getting a head, 0.5 chance of getting a tail. Right, so I've got a coin in my hand now. What I'm going to do is I'm going to flip the coin twice and I'm going to write down the outcomes. Right, so this is the first flip. Okay, so that landed on a head. And then I'm going to flip it a second time now. That also landed on a head. So out of our two trials there, we've got heads. So that means the probability of getting a head from that is 1. Because the only outcome we've had is a head. Right, so now I'm going to change it. I'm going to increase my sample size. I'm going to increase the amount of times that I do the experiment. Right, so first flip. So I've got a tail that time. Okay, next flip. I've got a head. Now I've got a tail. And I'll flip it once more. And I've got a tail again that time. Right, so we can see here that now I've flipped the coin 4 times, and the probability of getting a tail here is 0.75, and the probability of getting a head here is 0.25, because I got 1 head out of 4 trials and I got 3 tails out of 4 trials, so 0.75 for tails and a 0.25 chance of getting a head. So you can see that by just increasing my sample size by 2, I am already closer to the theoretical probability, the probability that I should obtain for this experiment. Right, so I'm going to do one more experiment. I'm now going to flip the coin 10 times. Okay, so first flip, that's a tails. Second flip, that's a head. Ooh, drop the coin. Third flip, that's a tail. Okay, fourth flip is a tail again. So fifth flip here, that's a tail again. Okay, now I've got a head. So is that the 6th? So 1, 2, 3, 4, 5, 6. Okay, I've got a head again there. Okay, now I've got tails. So that's 1, 2, 3, 4, 5, 6, 7, 8. So I've got to flip the coin 2 more times. So okay, so I got a head that time, and then the last time I got a head again. Right, so let's have a look at the probability of getting a tail now. Well, I've flipped the coin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. What's the probability that I've got a tail there? Well, I just need to count how many times I've got a tail. So 1, 2, 3, 4, 5. Well, 5 out of 10, that's a half, so 0.5. And then what's the probability of getting a head here? Well, how many times have I got heads out of 10? I've got 1, 2, 3, 4, 5, so 5 out of 10. Well, that's 0.5. So as you can see, now the probability that we've got from that experiment with 10 trials, a sample size of 10, that has come out at exactly the theoretical probability, so what it should, in theory, come out as. So I hope you can see that the trend here is that the more trials that we do, the more likely and the better that our data is in comparison to the theoretical probability that we should get. So I don't just have to stop at 10. I could flip the coin 100 times, 1,000 times, 10,000, 100,000, a million times. And generally, the more trials and the more experiments that I do through flipping the coin, each time it should get closer to the theoretical probability. Obviously we were bang on with the 10 flips, but as we increase we should still get the theoretical probability. So for experiments and tests, if we want to get close to the theoretical probability, so close to the theoretical probability, we need to increase the sample size. So increase increase the sample size. So to get close to the theoretical probability, we need to increase the sample size. So if we investigate a dice, well, we've got a 6-sided dice. So what's the probability of getting a 1? Well, a 6th. What's the probability of getting a 2? A 6th. Probability of getting a 3. A 6th. 4, 5, and 6. So they're all a 6th. Well, if we only roll the dice 100 times, so if we roll the dice 100 times, we would expect that we wouldn't get 1, 2, 3, 4, 5 and 6 as equal probabilities. That's what we would expect. But if we roll the dice 1,000 times, so 1,000 times, we would expect that the probabilities would be closer to the theoretical and therefore better than rolling the dice 100 times. So then we could obviously roll, I don't know, 1,000,000 times. And then we would expect that the probabilities would be closer to the theoretical probability than rolling 1,000 times, and obviously then rolling 100 times. So as I say, the idea is that if we increase the sample size of the investigation or experiment that we're doing, the closer the outcome will be to the theoretical probability.